Hi everyone, it's Mr. Kwan here. Today we're going to talk about regression. Now, what is regression? Regression is a tool that mathematicians and statisticians use in order to model data. And oftentimes we want to model data so that we can make predictions about either the future or about data during periods where we might not have information about that specific period or for that specific unit or something like that. Now, we are currently in the middle of a pandemic, a global pandemic. And so, it is really important to use regression here because mathematicians and statisticians want to try to predict and understand how this COVID-19 virus is spreading. And so we're going to use some math and statistics to try to figure that out. Now, if you notice here, I have an Excel sheet pulled up. I'm going to show you how to do regression in Microsoft Excel. With your student email, you should all be able to access Microsoft Excel. So if you download Microsoft Excel and log in using your college student account, you should have free access and not be required to pay anything. Okay, later I will show you how to do regression on a graphing calculator as well, but for right now, we will be doing this in Excel. Now, I have pulled this data from the World Health Organization Daily Situations Report around COVID-19. However, I pulled this data back in March. So the day that I pulled this data was on March 16th of 2020. So I only had information about the actual number of cases worldwide up until March 15th of 2020. So what we're going to do now is first things first, I think we should make a scatter plot. And a scatter plot is just a graph of all of these ordered pairs. So let me show you how to do that in Microsoft Excel. Okay, so what I want to do is I want to highlight these two columns here, including the titles there. And then I'm going to go up to this tab and click Insert. And then here, if you click this button, it says recommended charts. I'm going to click that. And the first chart that they give is kind of nice. However, all of the ordered pairs are connected, and I don't want them to be connected. I just want them to be separate ordered pairs. So I'm going to go over here to all charts, and then I'm going to come down here to where it says XY scatter and click on that. And then I want this second graph here. So I'm going to click that, and that will give us our scatter plot, or sometimes it's called scattergram. And I'm going to make that a little bit bigger so that you can see that. And first of all, this is an example of a bad graph because there are no titles for the axes. So I'm going to add those in really quick so we know that what exactly we are measuring. So I've gone ahead and I've added these titles. So the horizontal axis represents the number of days after February 22nd, 2020, and then the vertical axis represents the total number of cases of COVID-19 worldwide, not just in the United States, but worldwide. Okay, so the type of regression that we're going to talk about first is called linear regression, and it's probably the most common type of regression that you will see. And what linear regression is it basically gives you what is called the line of best fit. So what we're going to do is we're going to, on this graph, create a line that comes very close as possible to all of these points so that we can use that line to make predictions. So how we're going to do that is if you right click on any of these ordered pairs and then go down to the option that says add trend line. And oh, look at that. So under trendline options, there's a bunch of different graph options, but the linear one is already selected for us. So that should be the default. Now, if you come down here, you're going to want to click these two checkboxes, the one that says display equation on chart and the one that says display R squared value on chart. So I'm going to, once you click those, it'll populate this little text box here. I'm going to make that a little bit larger so that we can more easily read that. All right, so what does this tell us here? Well, the top line here, y equals 3001.9x plus 67,213, that is the equation for this line right here. Again, this is called the line of best fit, and it is used to, or the way that Microsoft Excel calculated it was that it used mathematics to get a line that's as close as possible to all of these points. So this is what we're going to use to make our predictions. Now this thing here where it says r squared equals 0.8778, that is a measure of basically how good our model is. And r squared ranges from 0 to 1, and we often think about r squared as a percentage. So this is close to 1, and if we thought about it as a percentage, we would say it's about 87%, which is pretty close to 100%. So this is a decent model saying that, this line does come pretty close to these points. Now, we're going to want to use this equation, and if you'd like, you can just plug in numbers for x, and then, x being the number of days after February 22nd, and then the y value, or the output, is going to represent these numbers here, the total number of confirmed cases that we're predicting for. Again, I just want to say, I pulled this data on March 16th of 2020. However, today is October 27th, 2020. And so we have more data to look at that we can compare to. But I am going to fill in some dates here. So in this box, I'm going to write a formula that will give me some more dates here. And I don't want to write all of the dates. I'm going to skip in intervals of 1 month, and we can do that by creating a formula. So I'm going to write equals, and then if you type date, and the first input for this function, I'm going to click this box right here, and then I'm going to write a comma, and then I'm going to put the number 1 to indicate that I'd like to skip by 1 month intervals, and then I will close that parenthesis and press enter. So now this formula has given me exactly 1 month after that date, and what I'm going to do now is I'm going to go to this text box here and press Control C and highlight a few cells down this way, and then I will copy that formula and paste it into these cells. So what that has done for me is now I've produced some dates that are 1 month apart, and then really what we want is this column here now, because we're not going to be plugging dates into our linear equation. We're actually going to be plugging in a number of days. So now what I want to do is I want to use a formula that will calculate the number of days between April 15th and our start date of February 22nd. So there is a formula that will do that for us. If you press equals and then press you want to type date and then DIF, which is short for date difference. So it's going to calculate the difference in those two dates. So the first entry is going to be the start date. So I'm going to click on this cell, and then after I click on that cell, I'm going to press F4 so that I can lock that cell down. I'm going to press comma, and the next input for this equation or function is going to be the end date, which is this cell here. And then the last entry or input for this equation or function is how you want the difference to be measured. And so I want them measured in days. So I'm going to put D inside of quotations for days, and then close that parenthesis off and press enter. So it produces 53, which tells us that April 15th, 2020 is 53 days after February 22nd, 2020. And I'm just going to copy this formula down to these cells, so it calculates the number of days after these dates as well. So I've copy and pasted that formula, so it gives me that. Now, this is where we're going to use this equation that we got from doing our linear regression. So I'm going to say that this cell is equal to 3001.9 times the number of days after February 22nd. So I'm going to click this cell here, and then we're going to add 67,213. So I have my formula there, and I'm going to press enter. Okay, so what that tells us is that our model is predicting that on April 15th, we will have approximately 226,000 cases worldwide, confirmed cases. Now, I'm going to copy this formula down so that we can see it for future dates as well. Okay, so according to our linear model, it is projecting that on October 15th, we would have had about 775,000 confirmed COVID cases worldwide. Now, today is October 27th, 2020, and I looked at the World Health Organization website, and the number of confirmed cases today is actually 43,341,451. That is a huge difference between these two numbers. We are like over 40 million off from what our prediction is to the actual number of cases to date. And so, although, this R squared value is about 87%, what that's saying is it's good for these ordered pairs here. It's a good prediction and it's close to all of those. However, we don't have more ordered pairs off on this side. When I did this data poll, I only had data up until March 15th. Again, but look how off this number is. And so what can we do to kind of think about this in a different way? Well, I told you that there are other types of regression, and this one was just an example of linear regression, but I'm going to show you how to do it another way. So I'm going to right click on this tab here and click Move or Copy, and I'm going to create a copy of it. And I'm going to rename this Exponential. Okay, so I have this data here. I'm going to go ahead and clear these. And then I'm going to delete my trend line. And so now I'm kind of back to where we were when we kind of first started, but I have my scattergram here. I'm going to right click on it and click Add Trend Line again. And instead of having a linear option, I'm going to click exponential. And let's see how the line changes here. Notice that it curved a little bit. And so here's a graph. That's what exponential functions look like. They increase at a faster rate than the linear does. So maybe this will be a better model for us. Let's click these two boxes here and see. All right, so look at this one. Our R squared, just given the data that we have here, is already better than the one we had for the linear function. We have an R squared value of about 93%. So now what I want to do is I want to use this equation here, this function, to predict for these dates again, and then maybe we can compare them to the linear one. All right, so let's start our function. I'm going to write equals, and then our coefficient is 71,578. And then Excel has this function stored in it called exp, and it returns e raised to the power of a given number. If you don't know what e is, it is a rational number. It goes on forever. It's kind of like pi, but the approximation for e is approximately 2.71. Okay, so my input for this is going to be the exponent of e, and if you come to our function, we want our exponent to be 0.0288 times the number of days, or our input. So I'm going to put, oops, I forgot to put a multiplication symbol because I want to multiply these. So I'll go back and change that. And then I want my exponent to be 0.0288 times our input variable, which is going to be the number of days here. And then I'll close that parenthesis and press enter. Okay, so now I'm going to copy that formula down so we can see the approximations for future dates as well. Okay, look at that. So here is the prediction using our exponential regression model. And this one is saying that on October 15th of 2020, it's estimating about 64 million cases, and that's a lot closer than we got with our linear model. Our linear model was approximating 775,000, so this definitely seems like a better fit. However, that's quite terrifying because what that's telling us is if we don't change the way that we're going about doing things, then by November and December, we're going to have a much higher number of cases. So I think that this activity that we just did is quite sobering. And if it says nothing else, is we want to make sure that we're taking steps to social distance, wear a mask, and make sure we're washing our hands so that we can prevent so many people from getting this virus. All right, so this was the thing that I wanted to show you as far as regression. We did two types of regression. We did linear and exponential, but as you saw, if you right click on the data point and you add trendline, there are multiple types of regression. You could even do quadratic regression. So if you click polynomial and make the order is just another way of saying the degree of the polynomial. So if you want the degree to be 2, then that would be a quadratic regression, and you could go all the way up to 6. So play around with these and see, maybe you could come up with a better model than giving us an R-squared value of 93%. All right, I will see you later.